Hey folks, welcome to another episode of ASP.NET Core from Zero to Overkill. In this episode we'll take a look at some tweaks that might be needed when we want to host our applications in multiple instances, so probably the norm in production when we want to scale our application or even just have some redundancy, not having just a single instance. Just a quick recap at what we were doing before. So we containerized all the components that make up the application using Docker, and then we use Docker Compose to get everything running easily, so it's easy for us to see the whole system running with a single command. In this one, like I was saying, we'll make some tweaks to allow for multiple instances, but the main topic will be ASP.NET Core's data protection APIs, how they impact what we have been doing, why has everything been working until now, but we are now talking about this, and how we can improve it. In the end, we'll just take a quick look at adjusting how Identity Server 4's development signing credentials are being set up, even though not really important, but as it's somewhat related to the other topic, we just take a quick look. But the main theme for this video will be the ASP.NET Core data protection APIs. Even though we won't use them directly, we'll try to understand how they impact our application and what we need to do to be able to have multiple instances of the services running correctly. And before we start, the usual plugs. If the videos are being useful, please like, share, and leave feedback. Leaving feedback probably the most important one, but the other ones also help the channel grow. And if you want more information, you can head to the blog where there are written versions of these videos. So you can watch the video or you can read it. And for more info, you can also check out my Twitter. With that said, let's get started. So let me just get back to the topics and let's start talking about these data protection APIs. So, heading to the docs, which is the best place to start, we can go in here, and the problem statement just is a clear way to tell us why these data protection APIs exist. So, I'm going to read it. I need to persist trusted information for lateral retrieval, but I don't trust the persistent mechanism. In web terms, this might be written as I need to round-trip trusted state via an untrusted client. So, in summary, and what is talked below, imagine a cookie where we store the client permissions, like it says here, but then the client could go to the browser, check out the cookie, and make adjustments and add some permissions. Then the cookie would reach our server and it would just accept the permissions because it's in the cookie. Of course, this cannot happen because it would be a massive security breach. So what happens is, using these data protection APIs, we can sign the cookie. So if someone tampers with the cookie, we know that it was changed, it doesn't fit the signature, so it's an invalid cookie. And this works for more things other than cookies, like tokens, JWT, stuff like that. So this is why these APIs are important. And even if, as I'm talking about the cookies, even if we don't use them directly, as we are not, so far in the series we haven't touched these APIs directly, but the framework does. So when we set a cookie, or maybe when we set it, maybe we need to do it ourselves, but the authentication part that the framework is doing for us, of course, it is setting a cookie and it's using this. When we go to Identity Server, also things are being signed so that everything works well. But we didn't touch anything, everything is working. So why am I bringing this up now? So let's imagine, we'll start with a sample. This is our Docker Compose file. Let's create another instance of the BFF. I'll copy this because I have already this prepared. Okay, so this is basically this another BFF is a copy of this BFF. Exactly the same, I just used another name, and this is a comment saying this is not the good way to implement these multiple instances, but it's quick and shows what we need to do. And we go to AJ proxy. In the BFF part, we can go and put server BFF2 is another BFF. So AJ proxy with this configuration will start round robin the requests to one instance or the other. So let's start this. Copy this. Start building. I built this previously, so hopefully it will be faster. Starting, okay. So we have the BFFs. Okay. Now over here I have the application. Seems to be working correctly, right? So now let's log in. And now, kaboom. Let's open here the network tab. We can try go again here, login, and kaboom. So what's going on? We can check out Docker logs. Oh, my mistake, not this one. This one. So there was an exception here, correlation failed. So correlation, when we started the OpenID Connect flow, it set up a cookie with a correlation ID, if I'm not mistaken, and other info. So when it get back from the flow, or better yet, we start the flow on our BFF, go to the auth service. When it gets back to the auth service, it comes with a correlation, so we can match the end of the flow to the beginning of it. But it is failing to correlate, and in the past it worked. Why? Well, imagine what's happening is it's starting the flow on one instance of the BFF, then going to the auth service, and when it gets back, it gets to another instance of the BFF. So it will try to check if the cookie or whatever it's being passed on, signed, is correct, but it cannot validate because it was signed using different keys. And why is that? Because the two instances don't know each other. So if we go here, there's these docs, important. All these links are in the blog post, so if you want to check them out, take a look at the blog post. But the keys used for data protection are stored in some places. For instance, when we are in Windows or in Azure, they are put in a specific folder, specific Windows folder. IIS does stuff, but we are in Docker, so they are completely different instances that don't know each other. So the keys aren't persisted and just are in the current process. So while the process is running, it works. When the process goes down, the key goes down, and in the next time, the keys are different. Besides that, given they are in the specific process, the BFF and the another BFF, being different processes, have different keys, so one cannot validate what the other signs. So what we need to do is make sure they use the same key to sign and validate. there are key storage providers in ASP.NET Core, several. We'll go with the simplest one, the file system, but there are other options maybe better, like Azure Storage, Redis, Windows Registry, Entity Framework, and given this, I'm pretty sure we also can implement our own providers if we wanted to store somewhere else, but we'll go with the simplest one, file system. Now you might be thinking, we're in a Docker environment, how will we do this because the containers are isolated? So we can use volumes with Docker. So it's like, I don't know if it's actually a container, but think of it like a container for data that we can share between other containers. For instance, is one of the recommended ways to store data for a database is instead of using the container with the database and the data in the same place, we use a volume. So the volume can be moved around, and even when the other containers go down, the volume stays up. But we're in dev mode, so we are not worrying about that. But now that we are talking about multiple instances, it's interesting to use these volumes. So we'll try to use them with Docker Compose. So what we'll do is, if you remember, we have the network services, and we'll add here, copy this, I prepared this part to make the episode faster, because we are always with these hour-long episodes, which are too much. I'll try to make them smaller from now on, if I can. Okay, but back to the subject. We add the volumes and we create a volume. And I created a volume named BFF Data Protection Keys. So this will be a volume where we can store anything. Now we need to put this in use by the BFF and the another BFF. So another copy paste here from the side. And we add here to the volumes, we say we want to use this one, which is the name we put down there, and we map it to a folder inside the container. So if in the container we use this folder, it will store things to the volume. And of course we need to go to the another BFF and add the same. This way they will share the same keys because they are in these volumes. This is done. This is what's needed for Docker Compose, but let's go to the code. We're here. This is the BFF repository, and in the startup class, we're in the end of configure services. This is all already there from the past episodes. In the end, we're going to add something to configure the data protection. For starters, let me just show you this. This is a simple class I created, just data protection settings, which has a location. This is not from ASP.NET Core. I created this class just to grab this part and create it in the Docker development application settings. Created an entry with a location, which is this varly BFF, which we configured here. Varly BFF stuff. So this is a path. So in here, in configure service, I'm getting the location from there. So grabbing the configuration section, as we already saw how to grab things from configuration, just grabbing it, grabbing the location. And if we have a location, means we are in Docker development mode and we can configure things. So I'll go in and add data protection, and then persist keys to file system. This is what we saw in the docs over here, persist keys to file system. So now we give it new directory info with the path, this one. So now it will persist the keys to this place and both will be able to share. So let's start this up again. This time it's taking a little longer because we changed the code, but hopefully not too long. Okay, all ready. Let's go back to the application, start over, log in, and it's working. We're back here. Now it's working. So it's doing exactly the same behind the scenes. It's going to the BFF, then going to the auth service, then redirected back to the BFF, but now they are able to validate the signature of each other because they use the same keys. One thing I won't do in this episode, but it's important to keep in mind, is encryption of the keys. So we are using a volume, but we are just putting the keys in clear text in that volume. So it might be important for us to encrypt the keys, and there are other ways. So protect with the Azure Key Vault, Windows specific to Windows. We can use a certificate to protect them. Other options. I won't go into details here, but it might be important. So I'll just drop a comment here. Because we should take this into consideration, but won't bother in this episode. Even the topic of this episode is probably too early, given the application doesn't do much. But as we are using Docker, it's a good way to show these kinds of problems. And maybe if you want to deploy a simple application, even being simple, if it has login, as soon as you put 2 instances, you'll have this problem. So I thought it would be useful to talk about it. So let's just get back to the topics. We already talked about this part. Go away. Already talked about this part. So why we have this impact? We are not going to use them, these APIs manually right now, maybe in the future, but right now just wanted to talk about that they exist, why they exist, why we care even if we are not using them directly, and we already improved the solution to use it. Now, very quickly, just take a look at this topic, because it's not really that relevant, but given we're talking about this broader topic, no harm in taking a look at it. So, in the same way that the keys need to be shared in Identity Server, besides these keys, which we should also configure, there is also the problem of the developer signing certificate. Ignore this part. What we had before was this. This is what was here in development. Now imagine that in Docker development we wanted to have 2 instances of the auth service, just because we want to test how it will work in production. Of course, we shouldn't use this developer signing certificate, the credential, in production. So we could do exactly the same strategy. We go here, We can I created this class exactly like the other one, just a string for the path, and we can give a file name to the developer signing certificate, and it will just work. So I added in the Docker development. So I created this path. That means we can go to the Docker Compose and add another volume to do this. And then we can have multiple instances of Identity Server. But again, this is just if you want to test in development how it would work with multiple instances. When we go up to staging, production, and all other environments you might want, we shouldn't be in this part of the if, we should be in this part and using a real signing credential based on some certificates or something like that. But just wanted to point out this topic. And that's about it. Going back here, we talked about all of this. Again, this last topic not very important, but this ASP.NET Core data protection APIs is important, and by already you know that this exists. So if you want to put something somewhere, like in cookies or in the even in parameters that you want to make sure the user doesn't tamper with, you can use these data protection APIs. If not, at least you know that the framework is using them, and it's important to have it correctly configured. That's it. Any question, as usual, feel free. Hope you enjoyed it, and hope to see you in the next one. See yous!